So this is an example of a problem where you're given a situation and the equation that models the situation. Then they're going to ask some questions. So what we need to know how to do is relate what they're looking for with the mathematical process that will find that. So here we're talking about a launched missile's trajectory, which is the path it follows. And it is quadratic, where x is the horizontal distance and y is the vertical distance, or the height. So two things we want to know. How far did it launch, and what was the maximum height? So for how far it launched, all right, let's get a little visual here, because if we visualize it, then we may have a better shot of knowing what exactly mathematically we're looking for. So if we just draw a missile, kind of quadratic, let's say it's like that. All right, the missile follows this path, goes up and comes down. So how far it launched? Well, we're going to start at 0, right, 0 feet, and then we want to find until it hits the ground. All right, that would be how far it launched. Now, how do we do that in math? Well, think about what numbers you want to know. We know we start at 0, but now we want to know this number here. Well, in a quadratic, that is called the x-intercept. Where it hits the ground is when y is 0. Right? The ground has a height of nothing, so I know I start at a distance of 0. I need to find what x value would make y 0, because that means it's hitting the ground. All right, so that would be task number 1. Let's find x when y is 0. So 0 equals negative 0.01 x squared plus 1.17 x plus 6.34. I would never try to factor this. I would never try to complete the square of this. I would just plug it into the quadratic formula and let my calculator handle it. So I already did that, and so negative b plus or minus square root of b squared minus 4ac. You have to be real careful, making sure you type all the numbers, watch their negative signs, just double check what you write. So there's the quadratic formula, and I've already calculated it, and I got that x equaled negative 5.19, and x equals 122.19. So x, remember, x is the horizontal distance it traveled. And so here, it means the rocket traveled negative 5 feet and then it hit the ground, or the rocket traveled 122 feet and then hit the ground. Only one of these is correct. It did not go backwards. All right. It went 122.19 feet. Now, normally we say only exact numbers, so like only radicals, no decimals. But in this case, in real life situations, you don't want a radical. You want to tell someone this is 122.19 feet. So for applications, you can get a decimal equivalent because that's how we communicate. In real life, we need some rounding. Okay, so this means that from 0 feet to 122.19 feet, that's how far it went. So question number 1 is answered. In red, it went 122.19 feet. It actually doesn't say feet, but I'm going to say it's feet. Okay, so and then the blue question, what was the maximum height it reached? Okay, so maximum height in blue is like right here on our graph. Now in math, we know maximum height to mean vertex. So since this is in standard form, we can find the vertex pretty quickly. So the vertex x value is negative b over 2a. So negative b over 2 times a. And again, this is just going to give us the x. Once we have this x, we'll be able to plug it in and get the y value. So the x, let me get this real quick, would be 58.5 feet. And so again, that is like here. That's how far out it went. And now to find how high up it went, we would plug that back in. So the y value, or the height, would be negative 0.01 x squared plus 1.17 x plus 6.34. So type all that in, and I got that y equaled 40.56 feet. All right, and that is the y, so that is the height. And since this is the vertex, we know that this would have to be the maximum height that that rocket went. All right, so the idea behind any application where you're given the equation is you're usually just finding like a minimum or maximum, which is vertex based, or you're finding like a distance that something went, which is usually x-intercept based. But in general, it helps to draw a little picture and then visualize what values or locations you're working with, and then equate that to some math process that we've been working with.